Hi guys, welcome to Chidre's Tech Tutorials educational YouTube channel. If you scroll down, you find Programming Language Tutorial section. In Programming Language Tutorial section, if you scroll to the right side, you find Python Tutorials playlist. If you click on View Full Playlist, you find all my Python tutorials where I am explaining Python in depth and step by step guys. In the previous videos, we started discussing operators in Python. We understood arithmetic operators, we understood assignment operators, we understood relational operators and logical operators. In this video, I would like to discuss bitwise operators in Python. What is the use of bitwise operators? Bitwise operators are used to perform operations on bits. Bitwise operators are used to perform operations on bits. In computer, bit means either 0 or 1 guys. Sequence of zeros and ones we call bits. Sequence of zeros and ones. So bitwise operators are going to perform operations on zeros and ones guys. We'll understand everything step by step, don't worry, okay? How bitwise operators work? How the bitwise operators work? To the bitwise operators, we give decimal numbers guys. Decimal numbers are converted to binary equivalent numbers, that is zeros and ones. Then they perform operation on bits of the converted binary equivalent number or numbers. They perform operation on bits of the converted binary equivalent number and return the result as a decimal number back. They accept decimal numbers, they return decimal numbers. But in between, they convert decimal numbers to binary, then they convert the result to decimal back. Okay, we have 6 bitwise operators guys. We have bitwise AND, bitwise OR, bitwise exclusive OR, bitwise complement, bitwise left shift and bitwise right shift. We're going to understand each of these bitwise operators step by step. So let's get started. Single ampersand symbol indicates the bitwise AND operator. It indicates bitwise AND operator. Bitwise AND operator says if both bits are 1, then the result will be 1. In all other cases, the result will be 0. If both bits are 1, then result will be 1. In other cases, the result will be 0. Let's have a demo and understand. Here I have the Python shell and the Python file. Here I say print 1 and 1. What output we get? Result will be 1. In all other cases, the result will be 0. If I say 1 and 0, result will be 0. If I say 0 and 1, result will be 0. If I print 0 and 0, it will display 0. Bitwise AND says if both bits are 1, then the result will be 1. In all other cases, the result will be 0. 1 0, 0 1, 0 0. You can see. Only when you have 1 1, result will be 1. So if I save this and say run module, you see we got the output same. 1 0 0 0, 1 0 0 0. So remember, bitwise AND says if both bits are 1, then result will be 1. Otherwise, the result will be 0. Okay. Here 1 and 1, what we are giving, they are actually the decimal numbers guys. They are actually the decimal numbers. Let's say here, if I say print 5 and 7, what output we get? If I say 5 and 7, what output we get? See, I told you what bitwise operators do. First, they convert the given decimal number or numbers to the binary equivalent numbers. And then they perform the operation on bits of the converted binary equivalent numbers and return the result as a decimal number back. So what happens? Let me explain more clearly here. We have 5 and 7. These are decimal numbers. First, they are converted to binary equivalent number. So how do we convert this decimal number 5 and 7 to binary? Very simple guys. We have to write 2 to the power series. Okay, we have to write 2 to the power series. 2 raised to the power of 0 is 1. 2 raised to the power of 1 is 2. 2 raised to the power of 2 is 4. 2 raised to the power of 3 is 8. We have to write the number which is greater than the given operands. Here 8 is greater than 5 and 8 is greater than 7. So we have to write 2 to the power series until we get the number which is greater than the operands here. Okay, and then what we have to do? We have to find the numbers. On adding them, we get the operands. Like here 4 plus 1 is 5, right? 4 plus 1 is 5. So underneath 4 we write 1, underneath 1 we write 1, remaining places we put 0. Okay, this is 1 0 1 means 5 because 4 plus 1 is 5. 7 means what? See, 7, how do we write 7 in binary? 4 plus 2 is 6, 6 plus 1 is 7. So underneath 4, underneath 2, underneath 1 we write 1, remaining place we put 0. So 1 1 1 indicates 7 guys. 4 plus 2 is 6, 6 plus 1 is 7. So under 4 1, under 2 1, under 1 1. On these bits the binary operations is done. So decimal numbers are converted to binary equivalent number. On the bits the operation is done. And what bitwise AND operator says? If both bits are 1, result will be 1. Otherwise result will be 0. If both bits are 1, result will be 1. Otherwise 0. So we got again result in binary. This binary result is again converted back to decimal. So how do we convert this binary to decimal? Again same thing. We take these numbers 0, 1, 0, 1. Above the numbers we write 2 to the power series, guys. So 1, 2, 4, 8. Next what we have to do? We have to add the numbers above 1. So above this one we have 4. Above this one we have 1. 4 plus 1 is 5. 4 plus 1 is 5. So what output we get? 5. Because 1, 0, 1 is 5. See, 1, 0, 1 is 5. Because 4 plus 1 is 5. If I run this code, definitely you will see 5 displayed. We will get the output 5. If I say run module, you see we got the output 5. Understanding? Great. So that is how the bitwise AND operator works. I hope you guys have clearly understood. Right? Next we understand bitwise OR operator. Bitwise OR operator says if both bits are 0, then the result will be 0. Otherwise, the result will be 1. See, it's opposite, you can see here. Bitwise AND says if both bits are 1, result will be 1. What bitwise OR says? If both bits are 0, then the result will be 0. In other cases, the result will be 1. Let's have a demo and understand. Okay. Here I have the Python shell and the Python file. If I say here 1 or 1, okay, I'll copy this and paste down 1 or 0, 0 or 1. I say here 0 or 0. What bitwise OR operator says? If both bits are 0, then the result will be 0. In all other cases, the result will be 1. In all other cases, the result will be 1. In all other cases, the result will be 1. So 0 or 0 will get 0. In all other cases, the result will be 1. If I save this and say run module, you see we got 1 1 1 0. Right? So bitwise OR says if both bits are 0, then result will be 0. Other case, result will be 1. What happens if I say print 5 or 7? What output we get in this place? What output we get? Now let me explain. Okay, I delete everything. This time we have 5 or 7. What output we get? First, these decimal numbers are converted to binary equivalent number. So how do we convert? We write 2 to the power series 1, 2, 4, 8 until we get a number which is greater than the given operands. 8 is greater than 5. 8 is greater than 7. So we'll stop here. Okay, we don't write 16, 32 and all. Fine. Next, underneath 4 I write 1, underneath 1 I write 1 because 4 plus 1 is 5. Remaining places 0. 4 plus 2 plus 1 is 7. So underneath 4 I write 1, underneath 2 I write 1, underneath 1 I write 1. Remaining place I put 0. So this is 7. On these bits, the binary OR operation is done. What binary OR operator says? If both bits are 0, result will be 0. In all other cases, the result will be 1. We got 1 1 1. So what do? We write here 0 1 1 1. Above these bits we write 2 to the power series again 1 2 4 8. Above the 1 we have 4 here. Above this one we have 2. Above this one we have 1. 4 plus 2 plus 1 is 7. Right? 4 plus 2 plus 1 is 7. So we will get the output 7, guys. Let's see that. I'll go to Python shell and Python file. I'll save this. Definitely we will get the 7, guys. I say run module. You see that we got the output 7. Let me show here. You see we got the output 7, guys. So that is how the bitwise OR operator is going to work. Understanding? Or binary OR operator we say. Great. Next we have bitwise exclusive OR operator. Bitwise exclusive OR operator says if both bits are same, then the result will be 0. That means if both bits are 1 or both bits are 0, result will be 0. If bits are different, that means 1 0 0 1, then the result will be 1. Okay, let me explain it with the demo. I go to Python shell and Python file. Here I say print, same as usual 1, exclusive OR 1. Caret symbol indicates exclusive OR, guys. Okay, I'll copy this and paste 1 2 3 times 1 1 1 0 0 1 and 0 0. What bitwise exclusive OR operator says? If both bits are same, then result will be 0. If both bits are same, result will be 0. If bits are different, then result will be 1. If bits are different, then result will be 1. So we should get the output 0, 1, 1, 0. I save this and say run module. You see we got 0, 1, 1, 0. 0, 1, 1, 0. I hope you guys have clearly understood. What happens if I say print 5 exclusive or 7? What output we get here? Okay, let's see. See here, we have already converted 5 to binary, 7 to binary. Here I will change this to exclusive OR. Here I will change this to exclusive OR. So what exclusive OR operator says? If both bits are same, result will be 0. If both bits are same, result will be 0. If both bits are different, result will be 1. If both bits are same, result will be 0. Right? This time we got, what we got? We got 0, 0, 1, 0. We got 0, 0, 1, 0. So above these bits we write 2 to the power series. 1, 2, 4, 8. You can see above this one we have 2. So we will get the result 2 guys. So you just need to add the numbers above the 1 guys. So in our case we don't have more 1, single 1 we have. So above this 1 we have 2. So we will get the output 2 guys. Okay, let's see the output. I save this and say run. Definitely you will get the output 2. So understand these things guys. Bitwise AND operator says if both bits are 1, then the result will be 1. In all other cases result will be 0. Bitwise OR operator says if both bits are 0, then result will be 0. In other cases result will be 1. Bitwise exclusive OR operator says if both bits are same, then result will be 0. If different, then result will be 1. Next we have bitwise complement operator. What bitwise complement operator says? Add 1 to the given number and change the sign. Add 1 to the given number and change the sign. Let's have a demo and understand. Here we have Python file and Python shell. So if I say print 5, definitely will get 5. If I say here complement of 5, what output we get? See, we have the operand 5. What bitwise complement says? Add 1 to the given number. 5 plus 1 is 6. 6 is a positive number and change the sign. Add 1 to the given number and change the sign. 5 plus 1 is 6. So result will be minus 6. If I save this and say run module, you see we got the output minus 6. Right? So if I give here 7, what output we get? 7 plus 1 is 8. 8 is a positive number. Change the sign. Minus 8. If I save this and say run module, we'll get minus 8 guys. So that is how the bitwise complement operator work. Add 1 to the given number and change the sign. Next we have bitwise left shift operator, bitwise right shift operator. See here, if I go and say print 1 left shift by 4 positions, what output we get? 1 left shift by 4. What output we get? See, we have a formula to find out. For left shift, simply you write the first number multiplied by 2 to the power second number guys. You write the first number, multiply it by 2 to the power second number. So in our case, we have 1 is the first number, 4 is the second number. Okay. So see what we have? 1 left shift by 4. So what left shift says? Write the first number multiplied by 2 to the power second number. 1 multiplied by 2 to the power 4 is 16. 16 into 1 is 16. So when you say 1 left shift by 4, you will get the 16 result guys. Let me show that. I'll save this and say run module. You see we got the output 16. So this formula you remember guys. Write the first number multiplied by 2 to the power second number. Here right shift, instead of using multiply by, we use divide by. Write the first number, divide by 2 to the power second number. See, for that I'll show you an example here. If I say here 16 right shift by 4 positions, what output we get? Very simple. 16 right shift by 4. You write the first number. Instead of saying multiply by, you say divide by here. 2 to the power second number. 16 divided by 2 to the power 4 is 16. 16 divided by 16, result will be 1 guys. So if I run this code, definitely you will see 1 displayed here. I save it and say run module. You see we got the output 1 guys. So that is how you can find the results for all the bitwise operators. I hope you guys have clearly understood. Bitwise operators are used to perform operations on bits, that is zeros and ones. And how bitwise operators work? First they convert the given decimal number or numbers to their binary equivalent number, that is zeros and ones. and then they perform operation on bits, zeros and ones of the converted binary equivalent numbers and return the result as a decimal number back. Okay. Bitwise AND operator says if both bits are 1, then result will be 1. Other cases, the result will be 0. Bitwise OR operator says if both bits are 0, then result will be 0. Otherwise, result will be 1. Bitwise exclusive OR operator says if both bits are same, result will be 0. If bits are different, then result will be 1. Bitwise complement operator says add 1 to the given number and change the sign. Bitwise left shift operator says write the first number multiplied by 2 to the power second number. To find the result of the expression where you have right shift operator, it is telling write the first number divided by 2 to the power second number. That's all about bitwise operators, guys. I suggest you people to watch this video 1 or 2 times, execute the codes whatever I explained. If you still have any doubts, feel free to put them in the comment section, guys. At least watch this video 2 times so that you understand the bits concepts, okay, the binary and decimal concepts. Understand these bitwise operators because they are very important operators in Python. For this video tutorial, this much is enough, guys. If you like this video, hit the like button and share with your friends so that everyone will get benefited. In the upcoming video tutorials, we discuss more about Python. For more benefits and be up to date, do not forget to subscribe to our YouTube channel. Keep learning, keep coding, keep sharing. Thank you, guys. Thank you very much. See you in the next tutorial.